Welcome back to the Deep Dive. Today we are digging into a huge topic, a question that's fundamental for anyone building in the cloud.
Yeah,
How do you build a real, actual fortress for your application?
that's the perfect way to frame it. If we think of identity and access management, IAM, as the bouncer at the front door checking IDs.
Mm-hmm.
Today, we're going past the bouncer. We are getting inside the building. And our whole mission is this idea of defense in depth.
Defense in depth. So if the bouncer messes up, you're not totally exposed.
Exactly. The walls, the internal locks, the sensors, they all still have to hold up.
And that's fortification, right? We're talking about the core of designing secure workloads.
Yeah.
Segmenting your network, hiding your secrets, and shielding the perimeter from some really nasty attacks.
Right. Things like DDoS attacks or SQL injections. It's not just about who gets in anymore. It's about what they can see and where they can go once they're inside. Every single layer.
Okay, so if you're listening right now, just take a second and think about your own application environment. I want you to ask yourself, where would you put your most valuable, your most sensitive data?
Your database, your user files.
Yeah, because that one decision, how isolated you make that resource, that's the foundation for everything we're about to get into.
It really is.
So let's start there. Let's build the walls.
Okay, so the foundation, the very first thing, has to be the virtual private cloud, the VPC. This is your foundational wall, isolating you from everything else in the cloud. And the number one still here is network segmentation.
And segmentation. In the VPC world, that just means subnets.
That's the tool, yes. You immediately break it down. First, you have your public subnets.
Okay.
These are for things that absolutely have to talk to the internet. Think about your load balancers. They're the front door for your users' traffic. They need to be public.
And then everything else, the important stuff, goes somewhere else.
Everything else, what we call the crown jewels, goes into private subnets, your databases, your internal application servers. These should never, ever have a direct route to the public internet.
Okay, but that brings up the first big problem, the paradox everyone runs into. My database is safe and sound in its private subnet. Perfect. But it still needs to download a security patch. Or maybe it needs to call out to a licensing server. How does it do that without me just, poking a hole in the wall?
That is the classic problem. And the solution is an amazing piece of architecture called the NAT gateway.
Okay, what does it do?
The NAT gateway lives in your public subnet. It's the only thing that talks to the internet on behalf of your private resources. So your database sends its request to the NAT gateway.
Which then goes out to the internet for it.
Exactly. It makes the request, gets the response, and passes it back. The key is no one on the internet can initiate a connection back through the NAT gateway to your database. It only works for outbound traffic.
Ah, so it solves the paradox. Isolation, but you can still do maintenance.
You got it. It keeps the fortress walls intact.
All right, walls are up. We've got our segments. Now we need the traffic cops inside the walls. And this is a topic that I swear trips everyone up. Security groups versus network ACLs.
Or NACLs.
And it's not just, an academic difference. It's critical for how you design and audit your security. They both filter traffic, but they do it in very different ways.
Let's nail down the stateful versus stateless thing, because that's the real key, isn't it?
That is the absolute key. Let's start with security groups, or SGs. They work at the instance level. So they're like a personal bodyguard for your EC2 instance.
Okay.
And they are stateful. This is the smart part. They remember the state of a connection.
The smart receptionist analogy.
Precis. If your instance sends a request out to Google on port 443, the security group sees that. It remembers. So when Google's server sends a response back, the SG automatically lets it in. You don't need a separate rule for the return traffic.
I see. It knows that packet is part of a conversation it approved. Right. Now compare that to network ACLs. NACLs. They work at the subnet level. They're a big, rigid gate for the entire neighborhood, not a personal bodyguard.
And they're stateless.
Completely stateless. They have no memory. This is the rigid security gate.
So what happens when my instance sends a request out and the response comes back?
The NACL has no idea you just left. It sees that incoming packet and says, "Who are you?" You need an explicit rule to allow the outbound traffic and a second, completely separate rule to allow the inbound return traffic on the right ports.
Even for the response to a request you just made.
Even then. And people always forget to allow the return traffic on those high-numbered ephemeral ports, and then poof, their application breaks and they don't know why.
So that's the real trap. You layer them.
Yeah.
NACLs for broad rules the subnet border, and security groups for specific rules on the instance itself.
That's defense in depth. One is a blunt instrument, the other is a scalpel.
Okay, internal flow is locked down. But what about the really malicious stuff, the brute force attacks coming from the outside, just hammering on our front door? Let's talk about edge defenses.
Right. This is where we need services that are built to just absorb and deflect massive amounts of junk traffic. For those huge volumetric attacks, like a DDoS, your first line of defense is AWS Shield.
Now, everyone on AWS gets some of this for free,
To
right?
do. Shield Standard is on by default for every customer, and it's very good. It protects against the most common types of infrastructure layer attacks.
So when do you need to pay for more? When do you need Shield Advanced?
You upgrade to Shield Advanced when downtime is incredibly expensive for you. Think major e-commerce sites, financial services. Advanced gives you much higher levels of protection, 2-force event access to the AWS DDoS response team, and even some financial protection against billing spikes from an attack. It's a business decision.
Got it. So Shield handles the sheer volume. But what about the smarter attacks? The ones that aren't just about volume, but are trying to trick the application code itself.
That's layer 7, the application layer. And that's where you need the AWS WAF, the web application firewall. I mean, one time I saw a client get their customer list pulled in under 5 minutes from a simple SQL injection on their login page.
Ouch. So what's the way of looking at that Shield isn't?
The Wave inspects the actual content of the web request. It's looking for patterns. It can identify the signature of a SQL injection attack or a cross-site scripting attempt, XSS.
So Shield protects the pipe, WAF inspects what's flowing through the pipe.
Perfectly put. Wave stops someone from using your own application against you.
That's a powerful combination at the edge. Okay, let's pivot inside again to one of the biggest mistakes people make. Storing secrets like database passwords or API keys in their code.
Or in an environment file in plain text.
Yeah, what's the modern, robust way to solve that? Why do we need a celestial service for this?
Because it's not just about storage, it's about management. And the single most important word here is rotation. Automatic rotation.
I definitely don't want to be waking up at 3 a.m. to change a database password on 50 different servers.
No one does. And that's why you have AWS Secrets Manager. It's built for credentials that need to be changed regularly. It can connect directly to your RDS database, change the password every 30 days automatically, and your application just pulls the new one. No human, no restart needed.
So if you hear the word rotation, you should immediately think Secrets Manager.
Immediately, yes.
But if it's so good, why wouldn't you just use it for everything? What's the catch?
Cost. That's the architectural trade-off. Secrets Manager has a cost per secret, and it charges you for every API call to retrieve the secret. If you have an app that's calling for a secret millions of times an hour, that bill can get very big, very fast.
So the access pattern matters a lot.
A huge amount. So for simple static stuff, an API key that rarely changes, you use the cheaper, simpler option. Systems Manager Parameter Store. It's great for basic config values, simple storage, parameter store, dynamic, rotating secrets, Secrets Manager.
That's a great distinction. Okay, secrets are hidden, edge is defended. Now, who's watching the system 24/7? Who are the detectives looking for subtle signs that something is wrong?
This is where the machine learning services come in, and they are incredible. We've got two main players here, GuardDuty and Macy.
Let's start with GuardDuty. What's its job?
GuardDuty is your broad threat detector. It's constantly analyzing your logs, VPC flow logs, CloudTrail, DNS logs, looking for weird, anomalous behavior.
What's an example of weird?
Let's say one of your web servers, which normally just serves traffic, suddenly starts communicating with an IP address in a foreign country known to be a Bitcoin mining command center. GuardDuty sees that deviation from the baseline and immediately raises an alarm.
So it's looking for signs that you've already been compromised.
Exactly. Now, Macy is a specialist. Its job is all about data classification, specifically inside your S3 buckets.
Okay, here's the scenario. A developer accidentally makes an S3 bucket public. Which service yells first? GuardDuty or Macy?
That's a fantastic question. GuardDuty might flag it if it sees weird access patterns like a huge download, but Macy will yell first because its whole job is to scan the content inside that bucket.
So it's looking for PII.
Personally identifiable information.
Yeah.
Exactly. It uses machine learning to find credit card numbers, social security numbers, health records data that should never, ever be in a public bucket.
So GuardDuty watches behavior, Macy watches the data itself.
You got it. It's essential for compliance.
Okay, last major piece of the puzzle. Most big companies don't live 100% in the cloud. They have on-premises data centers, offices. How do we securely connect that world to our AWS Fortress?
Yeah, the hybrid cloud reality. You've got two main paths here with really different trade-offs.
What's the fast and easy way?
The quickest way is a site-to-site VPN. You're essentially creating a secure encrypted tunnel over the public internet between your office and your VPC. It's relatively quick to set up.
Encrypted over the internet sounds pretty good. So why would anyone need more than that?
The keyword is internet. It's secure, yes. But the performance is unpredictable. You're subject to all the normal internet congestion and latency. You have no guarantee of consistent bandwidth.
I see. So for some things, unpredictable is a deal breaker.
For a lot of things. Which brings us to the gold standard, AWS Direct Connect.
What's so different about it?
It's a dedicated, private, physical fiber optic cable that runs from your data center directly to an AWS location. It completely bypasses the public internet.
A private pipe.
A private pipe. You get consistent, low latency, guaranteed performance. The trade-off is it's much more expensive and takes longer to set up because you're provisioning a physical circuit. But for things like real-time financial data streams, it's the only real choice.
Wow. Okay, we have covered so much ground today, from the VPC walls all the way to a private fiber connection.
And the main thing to take away from all this, the concept you have to internalize, is defense in depth. It's all about layers. The idea that if one layer fails, if your WAF misses something, the next layer, like the NACL or the private subnet, is still there to stop the threat.
So, to recap our fortress design, we build the walls with VPCs and subnets. We control the flow with stateful security groups and stateless NACLs. We defend the edge with WAF and Shield. We hide our secrets with Secrets Manager for rotation and parameter store for simple config. And we watch everything with the detectives. GuardDuty for behavior and Macy for sensitive data. That is a truly secure design.
If you can explain how all those pieces fit together, you've mastered the heart of secure architecture.
Okay, before we wrap this deep dive, let's leave everyone with a final thought to chew on, something that ties this all together.
All right, so think about this. We've built this incredible fortress, all these layers, WF, Shield, NACLs, private subnets, but the entire system assumes that the person or machine accessing it was properly authenticated at the very beginning.
At the front door, with IAM.
Right. So here's the question. What single, common, and often overlooked configuration mistake in an IAM policy, the bouncer's instructions, could make this entire fortress, all the walls and guards we just built, completely and utterly useless?
A perfect place to end. That brings it all full circle. Thank you for joining us on this deep dive into designing secure applications. We'll catch you next time.